Hey folks, Quillyteen here. About a week ago or so, Unity 5.6 dropped, and I actually got quite a few requests from a handful of people asking if I would do a video covering those changes, and I thought that would probably be a pretty good idea to do. So we're going to use one of our programming videos to do that. Seemed pretty smart, because there's a lot of new, really good stuff in 5.6 that's important to talk about. Now, there's going to be plenty of things in here that are maybe sort of on the fringe or incidental or not really related to some of the stuff we're going to do, so I might just go and scroll past that a little bit sooner. But some of the patch notes are quite relevant. So some of it we're just going to talk in here. I do also have a project over here. We might try and fiddle with some of the new features and see how they go. First of all, you probably can upgrade to 5.6 perfectly fine without breaking any of your projects, especially if you're running on Unity 5.4 or 0.5 or something like that. Almost certainly is not going to make any changes to your project in any way whatsoever. But if something does go wrong, you do always have the ability. You can access every version of Unity that's ever been released. You can always re-download that and reinstall an earlier version if there is an issue. So, there's a few notes here and a couple more that are coming up that have to do with tweaking the mesh that is used for sprites, the tessellation quality, and the ability to edit the mesh down below. This is something that may not come up very often. It is a neat little feature that's been added in. The thing to remember is that in Unity, it's still, and sort of its core, a 3D engine, and therefore even a 2D sprite gets rendered as a mesh with a texture on it. And while you could use a bunch of quads for absolutely everything, Unity actually does use just meshes that aren't quads, that are more sort of polygons that hug the shape of the sprite quite a bit more often. I think it makes it a lot easier for it to calculate sort of transparencies. Obviously, this also ties into a lot of the 2D physics engine kind of system. So now there's going to be more options for controlling that, which is fine. The 2D sorting group is something that I think is a lot more practical and is going to come up a lot. This is actually an issue that people have probably run into in the past. So the idea is you can, when you're doing 2D sprites, assign your sprites to a render layer. This determines the order in which the sprites are drawn. And for example, if you had a game where you had this zombie character and you had the body and you had the arms on as separate sprites, that way you could like animate the arms or swap arms in and out for different animations or actions or something like that, right? So the idea, you have one sprite which is the zombie's body and another sprite which is the arms. By setting the arms on a render layer that is above the zombie's body, then the arms will always render on top of the zombie's body, right? So that way the arm's always in front of the zombie, like this, instead of behind the zombie. The problem is that when you have two zombies that cross each other, what happens here is both zombie bodies get rendered in the background, and then both zombie bodies get rendered in the foreground. It's actually even worse here because clearly the zombie head is on a separate layer as well, a separate render layer, because they want to be able to animate the head as a separate thing. So you've got the head floating on top of this, and then the weird arm and all these things, right? So you can see what happened. The zombie that's in the back, the body's in the back, but the head and the arm is in front of the zombie body that's in the foreground. So the way around it was, instead of using render layers, you would instead do a bunch of weird tricks with like the Z indexing of the various sprites, and it was a little awkward. You could get it to work, but it was sort of annoying. Now they've got the ability to make groups of renderers, so that within your single instance, and that's what we're seeing down here, the fixed version of it, within the single instance, there are still render layers being used where the body's behind the head, and then the arm comes after that, but everything in one sprite group gets rendered as one group like that, so in front of the other zombie. So it's going to fix some of those like graphical issues that you otherwise would have to mess around with some Z indexing to fix manually. It's got another reference here to the ability to do some sprite outline editing, which is cool. Okay, and this is possibly one of the biggest ones that we've been waiting for a long time. 9-splice sprite rendering. What the heck are we talking about? Well, one of the things we've had for a while is 9-slice rendering for the GUI. So I have an image over here, right? I brought it in. This is one of the Kini.nl sprites that just one of these tile things. And if I open it in, say, the sprite editor over here, one of the things you could always do is drag down this border. So let's say I do this. It's going to be kind of awkward. This is not something that's clearly meant to be 9-sliced, but let's just pretend over here. So it's not going to look quite right. I can pull these borders in like this and define something kind of like this, to say that this is the top part, this is the bottom part, and these are the sides. And then if we apply that, if I had decided to make a UI image, so I'm going to make a UI image over here, and I'm going to apply that grass sprite to that. Okay, then if I take this UI image and we go into the editor, so 2D over here, double click on that so we can see it, and I start stretching it, you can see what happens. It doesn't stretch it only stretches the middle effectively, and the top stretches in a different kind of a fashion, right? It doesn't stretch the whole sprite evenly because of the way this license works. This is good for a UI element where you don't want your toolbar to stretch or your sides to stretch. Typically, you would do this with an image that is kind of blank in the middle, or has some sort of other repeating structure in the middle or something like that that can work. But this was working for in the UI, which has worked for a long time, but it didn't work in the 2D sprite system. But now that has changed. I haven't actually tested it yet, so I'm very curious to see what the deal is. So we've got our grass over here, and the draw mode is simple, so we can tell it well, I mean, you could always do tile before, which is kind of interesting. And what's neat about this is it is only tiling the middle part. Well, and it tiles the top like vertically because of our slicing, which is kind of interesting. There's continuous and adaptive. Ooh. Oh, that's very nice. That is very nice. Look, I like that effect. So now you can sort of stretch things in a variety of different ways, right? Because let's say we make another version of the grass texture over here, and this one here we leave in simple sprite mode. Obviously, if I stretch this out, we just get a bigger version of the same texture, right? So let's compare these side by side. This is in the simple draw mode, the normal way that it used to work. Here we are in tiled mode, and if I went and duplicated this again, brought it over here, and set this one instead to sliced mode, we can compare the differences between these two, or these three, especially if I sort of vaguely size them the same way. You can see how they get used in different fashions, and that's very cool to have these options. They're going to be very good for lots and lots and lots of little level design stuff going forward, especially if you use sprites that are like really well suited to whatever you're trying to do over here. But I mean, so there's clearly a massive difference between these guys, and it's going to be a lot of fun. I think this tiled, the 9 slice plus the tiled, is going to be the ideal way to make quick platformer levels, or top-down levels as well. It's going to work out really well for that, assuming you have the right sprites. And honestly, this is not a bad way for like our grass chunks, right? I think it more practically would work if you were doing like sort of little platforms like this. But what's great about it is you do it arbitrary. There's a shorter one and it looks fine, and then we'll have another one that's going to be really long, and for some reason we want this one to be slim. You know, hey, there you go. It really adapts to all of these things. This one's like a long pillar that you can go and stand on. Boom! Make your Mario World clone like that. What a gorgeous tool! We've been waiting for it for a really long time. It's going to be great to have it in our toolbox. AI low-level API for Nav Mesh Building. So I haven't looked at all the implications of this. So a Nav Mesh is what you can use to use the built-in pathfinder in Unity. Some time ago in Unity, they added in a built-in support for pathfinding using these Nav Mesh features, and that's what the AI thing is here. I mean, basically, it just does a pathfinding run, and then you can tell something to follow along a route. You know, it's not necessarily that AI-ish exactly, but it lets people wander around the map. It's got a bunch of different tools and options for generating these 3D pathfinding meshes for complex routes. So now we have a lower-level API for making changes to these at runtime, presumably quite quickly, and I'm sure is a very powerful and very useful tool, but we haven't really looked at this in depth, so I can't go and comment on what these things are. But based on some of the feedback that I've been seeing on online, it's a very, very good, very strong thing. If you are interested in having a map where the terrain changes in some fashion and you need to update the navigation mesh for your pathfinding on the fly, it's going to be really powerful. Tracking of animator, state machine, view positions, okay, sure. I don't really mean by view position. I mean, the animator state machine I get. Do they just mean, like by view position, do they just mean like where you are in the window when you're panning around and messing around with your state machine? It might not even be something in game. It might be something specific to the editor. I don't know. So we've exposed a few values over here. Build pipeline, support for metal compute on iOS, macOS. Okay, sure. Editor added tree view. I am GUI control, which can display hierarchical data that can be expanded and collapsed. I feel create list views, multi-column for editor tools. I believe this is the sort of thing that comes up if you decided to make a custom editor control, because you can do that for whatever your objects are, for some component that you've made. You obviously there'll normally be a default component information here, right? Any of your public data fields like a string or a float or whatever will show up in the inspector view over here, so you can edit, you can type things in, but you can make your own default version, which includes a lot of sort of custom controls and all kinds of different widgets and things like this. So to me, it sounds like they're including more types of widgets and controls for doing that, but I might be wrong as to what this is referencing to. Again, more editor stuff. Expose the following custom handle classes in the control. So box bounds handle, capsule bounds handle. So this thing here, which you can see, like this was existing before, right? Let's say we created a cube in the world. So this is not 3D, so I'm just going to go ahead and there. So we've got a cube. What you can do if you click, say, this edit collider here, we're now editing, say, the box collider using these box widget control kind of things. So there's a lot of these things that exist in Unity, and it looks like what they're doing is exposing more of these types of controls. So again, you can add some sort of custom control in the editor view for your object for all sorts of fun things. Very powerful. If you are extending the Unity editor with custom inspectors and custom controls in the view over here, you are going to have a much, much better, more powerful tool for modifying your game. Especially if your game's above a certain scope, you can like double your productivity by spending a little bit of time building these tools. So it's nice to have a few more options there. So it just sounds like it's more in editor stuff, which is fine. Again, editor reference over here, interactive handles for editing, primitives, etc. Same sort of thing, more commands, more flexibility, which is good. Again, this metal rendering background reference to the Mac. Okay. So in the editor, I think when you, these would be more of a preference thing. You can see more Visual Studio installs and get to choose which one you use when you're picking your external script editor. So for those of you who don't use Mono Develop, and may have more than one of these versions installed, life's a little bit better. Another reference over here. Facebook build target. So they've got their Facebook game room configuration on Facebook that you can target as you know, just like how you target Windows or Linux or Android or something like that, you can target that specifically as a Facebook Game Room Windows app, which presumably runs as some sort of plugin. I haven't looked into how this works, or WebGL, but in any case, it formats things properly. They can just flip it in there, which, hey, I mean, honestly, if you want to make a lot of money, make yourself a goddamn Facebook game. Even, like, you know, the crazy, crazy days of Farmville might be past us, but there's still so much money to be made by that, and they can be a lot of fun, so why not? Okay. Global illumination. This is the thing where a light shines on a surface, but then sort of reflects a little bit off the surface to reflect, you know, off the bottom of these platforms, for example. Little things like that. Global illumination, really, really good shadows, really nice and realistic lighting. So they've added more light modes, which are replacing previous light modes over here. Bacon shadow mask. So the shadow mask is pre-calculating where the shadows are going to be, for example. For lack of a better explanation. New lighting window layout. Actually, I'm very excited about that because the old one was kind of poop. So let's take a look what it looked. Ooh, settings and light explorer over here. So I mean, mostly the same stuff as before, but it is laid out differently. And distance, shadow mask, subtractive. Okay, so definitely some more options for lighting over there. We haven't really looked at a lot of the really advanced lighting tools, but one of the things I'm happy about, they're going to show it down below, I think, for the progressive light mapping. Don't they have a little animation? I guess maybe not built into here. But the progressive light mapper, the new one, looks like it's a lot better for working in the editor and making changes and having the lighting change on the fly. I mean, we haven't looked at anything that really needs any advanced lighting in any of our tutorials, but it was kind of kludgy and it felt slow. I think this is going to be very exciting. It just feels like things will just feel better as you're working, and I'm a big fan. I'm very excited for the ability to tune these various lighting modes. And this Light Explorer over here, this looks like a really great way to just at a glance see all of your lights and tune some of the settings. I think that's a nice little user interface that's going to be way, way, way more convenient. Oh, here's the animated example here of it rebuilding the light map. So you just rotated the light, and it's progressively going through and updating all of the little textures so you can see the change, you know, in semi-real time as it then catches up. So, you know, some more conversions, some extra features, I don't know, physically based rendering material validator. Okay, sure, yeah, I totally follow that. Support for procedural instancing, where instance data is supplied via custom shader source in the shader rather than from material property blocks. So the way I understand this is that, like, for all these crazy ass cubes in here, these guys will likely not be game objects inside of Unity where you have mesh data. Instead, you pass, I think, the default mesh to like the shader, and then in the shader, it knows that they're supposed to be all over the place. So you're offloading more of the work to the video card. So there's going to be less ability to do certain things with your meshes, but you can have tons more instances and have them go insanely fast, is I suspect the way it goes. Support for Vulkan. So Vulkan is quite interesting. Vulkan is a new type of graphics API, and it's basically an alternative to DirectX 11. As I understand it, the start of it may have been some work by AMD, like the Radeon people, and they open sourced it or gave it to an existing open source group or something like that. And it is a graphics API, assuming I understand it correctly, that can basically do all the really high-end, you know, nice support for lots of intense graphics and all the feature sets of something like DirectX 11. But if I understand correctly, it's a little bit more direct and a little bit more low level. It's supposed to be a lot faster. Like, it's good on PC, you know, PC, Mac, like desktop, counter console, or actual consoles like an Xbox or whatever, in terms of speeding things up. But in particular for mobile devices, it can also lead to greatly improved battery life as well. It looks like it's substantially more efficient. I know that there's a few games like Star Citizen, for example, is dropping DirectX 11 support and moving to Vulkan support, which it looks like it's going to be very exciting. Just an API, and also it looks like it's not just a Radeon kind of thing. As far as I can tell, the NVIDIA people are also going to be supporting it or do support it, which is really, really good news. So that's really nice to see. So, I mean, we can tune it. So, edit project settings player. We could go and enable it now. Edit project settings player. Presumably, you would do it for your PC, Mac, Linux standalone. And where would that be? DirectX 11 full screen mode. That's not it. Is it under other settings? There's that. It's not that. Oh, so they're changing the way they're versioning Unity from now on. I think 5.6 will be the last one called something like 5.6. And now we're going to be moving into Unity 2017, 2017.2, 2017.3, then 2018, etc. Anyway, for the first 2017 release, they are looking at potentially supporting the latest .NET, like, I don't know, 4.5 or something like that, which is going to be really, really, really exciting. So this is not part of what we're looking at now. Yeah, where the hell? So it's not this. This is for WebGL. This is for Android. I'm confuzzled. I mean, it's not the icon, it's not the splash image. I'm probably just not seeing it. It's not actually a big deal. Oh, wait, that's it. That's right. You have to unselect the Auto Graphics API, then you get to choose what you support. So by default, it'll try DirectX 11. If that fails, it'll go DirectX 9. You could remove things, you could change the order, and presumably here, there you go, you could add Vulkan. It's experimental. Normally, you're just going to use Auto Graphics API for all the settings. But that's right. That's why I couldn't see it, because you have to uncheck the auto thing before you get the option. It is weird that it's not like here and then grayed out, but I mean, I guess that's actually very legitimate and functional. You just have to remember that you have to hit that button. Okay, I was going crazy there for a second. All right, particles. Okay, new shape module to support non-randomized particle emissions. It looks very pretty. Redesign the burst emissions up to 8 bursts. Okay, that's fine. More better particles is more better. This is very exciting. So they've added a new composite collider 2D component, which merges together, presumably, children box collider 2D and polygon collider 2Ds. I suppose we can give that a little go right now and see how it goes. So let's say we have, let's get rid of the cube. Let's go back into the 2D mode. So we have, let's say this box over here and this one over here. And what I'm going to do is I'm going to add button. I'm like, why is there a butt in the search field? So box collider 2D, and we'll add a box collider 2D here as well. Now, let's say we had these two and they were overlapping. Now, there's no reason, so that's what, grass and grass 3. Okay, let's get rid of the others just to clean this up a little bit here. There's no reason you couldn't create, say, an empty, put both those inside there, And you can sort of bind them together by adding a rigid body 2D to there at that point. And if it uses gravity, which has got a gravity scale in there, so if we hit play, these guys should fall, and they should fall together. Well, we don't want full screen mode because that's just going to look funky. There, don't maximize on play. Okay, they'll fall together. And that's good and fine. But, and actually, could I... It's interesting that it didn't use the component size for the box collider. So let me just resize these better. But it still treats them as two sort of separate objects, and it's not maybe that relevant for the boxes, although there is going to be sort of a double density in terms of weight on the overlap bits. It's not very meaningful, but technically these two box colliders do overlap. And in particular, if you've got complex mesh colliders, like the polygon colliders, then you can end up with a fairly complex design. So I think the idea is, so collider 2D, what was it called? Composite collider 2D. If we do that, then presumably it's combining everything below it. Outline geometry is composed of edges and will not preserve the original collider center of mass. That's okay. The composite collider 2D is attached to a dynamic rigid body 2D, so we need to explicitly set these if required. Dynamic rigid body 2D. And presumably that's what they mean. Yep. Okay. So I mean, first of all, if we hit play, everything should work the way that it was before. But I'm wondering about like the look of it. Because in the preview, it looks quite cool. Clearly, especially at the start of this little GIF here, there we go. You can see the polygon, and then they're moving them individually, and then at some point, you're seeing them combine, and you're getting one contiguous proper set of outlines with the two of them. I don't know if I've set that up properly for this. I'll have to check the actual documentation for how Composite Collider 2D works. That might suggest that you set it up differently, but I think it's going to be very, very, very powerful to get more accurate center of mass calculations, as well as potentially simplifying the geometry to make the physics more accurate. Excited about this. This is quite cool too. So a bunch of these are 2D calls that you can call from the physics engine or from a specific collider or specific rigid body that will give you descriptions about the distance between two colliders. Basically like this. So you can see here it's calculating the distance to the nearest edge. It's possibly most notable over the polygon. So it's not nearest edge, I think it's nearest vertice. There's a couple of little blinks to the middle here, so I'm not sure if it's vertice or edge or whatnot, or may just be literally the closest point. Actually, that's probably exactly what it is. It tells you the distance to the closest point of a particular collider, which is really useful information to see. You can see the same thing here as the character translates here. It's pointing to the closest point on the collider, including when you're inside over here. That, I think, there's a lot of applications where you could see something like that being really useful. Overlap collider, cool. Attached collider count, sure, good reference. This is interesting. So box collider 2D and edge collider 2D now has a radius feature, which actually probably will make your life a lot simpler for a lot of 2D platformer stuff. These rounded edges tend to avoid, like even just a tiny radius on a rounded edge like this, tends to avoid a lot of weird little hang-ups as things are supposed to slide smoothly from one to the other. I suspect we'll see a lot of use of this, so I'm very excited for it. Yay! Debugging tools for physics. Sounds good. Daydream integration as a VR target. Okay, good. VR, excellent. Native crash support for iOS in reporting. Okay, that sounds really good. Additional shader properties to the canvas. Change the default behavior for all new canvas components that are created. Yeah, that's probably a little bit beyond my scope. So... okay, I see. So, by default, all of the things in your UI canvas, the information being passed to the shader was all this stuff. But most of the stuff isn't needed. Really, you just need position, color, and the one set of UV coordinates. You don't need the extras. So, the new default is to only send this, which means less memory being passed back and forth, it maintained in the canvas, maybe passed to the graphic cards, and so on. But you can tune and ask for more of these to be included in the shader by default, like this gets passed to all new canvas components. Presumably you can also do it on a component by component basis, which is nice, and even add some extra UV shader channels if you need, although if you start to need like 4 shader channels for the UVs, I don't know what would be involved in that. All right, video player. So they've had this like movie texture in here for a while. I've never seen it get a lot of use, and as I understand, it was never great. So now there's a new video player component and video clip importer asset over here. One of the other reasons that I don't think this saw a lot of use for a long time is because it required the ability to render to a render texture and then get applied to, say, like a quad or a cube or something like that, and that used to be a pro-only feature, although that hasn't been the case for some time now. So we have a new way to like import video clips and to apply them to textures like this, which is quite cool. They have a little animated thing. Is it going to be here? You're going to create the cube and then add it in. So in this little thing, there's going to be a background with an animation. And yeah, the sphere is also going to have a movie on it. So they're hitting play here. So a movie is playing on the sphere. And then, oh yeah, there you go. Video clip playing in the background as well. So it's nice to have that video integration. There's a lot of cool stuff you can do with that. And I'm actually wondering if I can use that for something nifty in our next Let 'em Dare. You know, do some built into the game video or some damn thing. I don't know. Vulkan support, excellent. Cardboard support, there's some more VR. VR. WebAssembly support, experimental, yes, but it's still a really good move. WebAssembly is, so JavaScript is, of course, the language of the web, right? In your browser, it's JavaScript. WebGL, always, whether you programmed in, you know, C# or whatever, when you exported a Unity project for WebGL, everything got converted over to JavaScript, so it could run in the browser. That's fine, but JavaScript has a lot going on it, and it's meant to be relatively flexible. You know, no strict typing for variables and so on and so forth, which makes it a great, very flexible language. But some of those things lead to slight speed bumps along the way. So WebAssembly, and there's another one too that's trying to do a similar thing, are ways to, it's sort of a subset of JavaScript. It still looks kind of JavaScript-y, but it doesn't include all of JavaScript, but the stuff it includes is very fast. It's allowed to remove a bunch of stuff that JavaScript had to include. So it doesn't let you do the same things that you could do in pure JavaScript, because some of those things meant that, you know, JavaScript would have to make some guesses and figure things out on the fly. So they've removed a lot of things that would require JavaScript to do extra work on the fly to figure out. So you have to be more strict with your programming, but the end result is it runs much faster. And so the idea here, and it's the support in browsers is starting to get in there. So this, presumably, is the ability to do a WebGL export that only targets WebAssembly as opposed to generic JavaScript, and should presumably run much faster. As far as I know, WebAssembly still doesn't support things like multi-threading, at least in the current, you know, configuration, but we'll have to see how that goes. So those are all the new stuff. Then there's a bunch of changes. Some of these I may or may not be relevant to anything we do. Camera render ordering, yeah, that's fine. No, I don't remember what the MS is. Type of anti-aliasing has been removed from most platforms because some things could be faster or simpler. Renamed a couple of namespaces / you know, sort of classes to be more consistent. Yeah, that's fine. A couple of behaviors have been tweaked a little bit. These are the sort of things that could potentially break some piece of code that you've got if you're using some of these features, which are pretty, like, these are pretty nitty-gritty that not a lot of people are using directly. So it's probably going to be fine. Removed some shader stuff. Oh, these were matrices, but use these versions instead. Yeah, I think most people were using these uppercase helpers most of the time. So, I mean, if you're doing some, again, some pretty grody shader stuff, you might have some references to the things that, as far as I know, these matrices have been available for a very long time. So I don't think this is anything new. I think it might be more of a case of removing some deprecated legacy stuff. I'm not sure, though. Yeah, this probably sounds like a good idea, because it's actually been quite tricky to debug some of these shader compilation errors in the past, because sometimes the errors really cascade in bizarre ways. So it probably is fine that it just stops after the first one. SDK stuff, yada, improvements, axis distance sort. A lot of these, I'm not sure that there's something that I would be aware of if it's happening. I'm excited about it. This is potentially one of the more meaningful ones. The default humanoid rig has an extra bone in the chest. So a third spine bone called upper chest here. That's probably pretty relevant if you're doing a lot of humanoid rig stuff. Presumably your existing rigs are still perfectly fine. It's just, you know, default new inclusions will have the extra bone in there. Might have some impact on your animations. You can probably still remove them. You can probably still tweak it, but that's a pretty significant change, actually, I think. We saw this above, added tracking of animator state machine view positions. And as far as I know, as far as I'm assuming, that just has to do with like the inspector and how I view it, but I might be wrong about that. Yeah, performance improvements for certain textures. A lot of this is more meaningful for mobile gaming than anything else, and depends on if you use those. You know, reduced memory and video usage. These are all good. Are they really things we really notice too much? Touchscreen in Windows, okay, that's good. More light mapping stuff, sure, fine. Oh, the frame debugger improvements. There's actually a really good one. Are they going to mention it? There we go. This one here. Frame debugger now gives a reason when draw call can't be batched with previous ones. This might seem like a little bit, what's going on here? One of the things in Unity, well, one of the things in any game programming is, of course, you want to improve the speed at which your program runs, right? And in particular, if you've got a 3D sort of environment, you want to improve, you want to make it so that you can render lots and lots of stuff as fast as possible. And one of the things that's kind of unintuitive at first, because people are always talking about polygons, and yeah, sure, more polygons take longer to render, but in fact, something that has a lot of polygons isn't quite that much harder. If you've got, let's say you've got an object with 1,000 polygons and two objects that each have 100 polygons, you actually might be surprised. It's possible, now I'm not going to say in all cases, as a for instance, it's possible that rendering the two objects with 100 polygons each will take longer than rendering one object with 1,000 polygons, because in fact the biggest overhead in 3D graphics, and remember your 2D graphics are really still 3D, is the number of draw calls. Every time you have to tell the video card, here's an object, here's another object. It's not as much the size of the object, it's every time you tell the renderer, here's an object, here's an object, here's an object, or here's a mesh, here's a mesh, here's a mesh. One of the things that Unity can do is batch some of these calls together. Take a handful of these objects, put them together into a single draw call, and say, here's this mesh, which actually is multiple objects, but we're going to pretend it's one mesh for the purpose of sending it to the video card. And that is what this batches are. Each batch is a set of draw calls, and saved by batching over here. Like, we're at 0 right now, so we're doing 2 draw calls at this time. And let's see, now that we're in edit mode, it's saved something somewhere. But in a real life application, you're going to get, you know, potentially, you're talking about hundreds, thousands of potential objects, and you might be able to trim those dramatically down. You might be able to only use 10% of the draw calls that you expected if things can be batched together. And there are ways to do that, like things that are, you know, sometimes marked static, things that have the same material can often be batched together. There's a bunch of things like that that you can do that for. And sometimes it's not always clear why certain things wouldn't be batched together. You got information, there's this many batches and you've saved this many batches. But so it's like, okay, if your batches are 1,000 and saved by batching is 500. So there would have been 1,500 draw calls, but there's only 1,000 draw calls. I'm just pulling numbers out of my ass here. You might be like, well, why are there still 1,000? What can I do to improve that further? Well, so there's the frame debugger, which, oops, is over here. And I think we have to start the program to be able to see it. Oh, enable. Let's try this again. Okay. So in here, was it... I mean, we're not getting any errors for well, where was it? In here somewhere, there will now be a line. There's not a screenshot down below, but there will be a line that tells you why it couldn't batch the previous one. Now we have sort of a really bad example over here. I might have to add more stuff to the view, but somewhere in this, it will give you information as to why it couldn't batch with the previous draw call, because, you know, there's something different in the lighting or material or something bizarre like that. So it can help you give you an idea why things aren't batching together, and maybe it's something you can change somewhere to get even more efficiency, which is great, which is very good. So that's actually worth talking about right over there. I think that might be... Oh, right, there's a bunch more particle stuff. Yes! Yeah, look at this. Oh, gorgeous. Just gorgeous. So there's some more particle stuff. There was some particle stuff up above. Here, hey, HDR things, which is great. Huge performance improvement for particle collision against 2D colliders. So one of the things, like, I did mess around one time. We made a tutorial where we basically invented our own 2D particle system. But the particle system does work inside of Unity itself as well. I used it mostly as an excuse to do other things. And particles, your average particles are relatively simple. The reason you'd want to implement your own sort of particle implementation is if you needed your particles to do a little bit more. But your particles will never be as fast or efficient as the built-in ones, because there's a lot of optimization that goes into these. And apparently they added a bunch more optimizations for 2D colliders with particles, which is really, really, really good. So that's very exciting because you can do some pretty things with particles. Yeah, there you go. Particle solver problems with colliders. Excellent. More particle stuff. Oh, yes. I think this might be related, honestly, to the change to the canvas we saw above, where you get more flexibility as to what data is sent to the shader. So again, presumably to give you the option of, or it might help it optimize those calls, but also if you need more information that, you know, the average particle doesn't, you can include more information getting past the shader so that your custom particle shader can do fancy schmancy stuff. Custom data as well. Excellent. Yeah, because you could add some of the stuff via script, but now you can do it via the inspector, add some custom data over here that you can then refer to in your code or in a shader, perhaps something of that nature. 2D contacts are shown. Yes. All right. So, I mean, just more information. Anything that gives you more information is always really, really handy dandy. Profiler, API changes. I think we're going to just have to fixes. And some of these might be things we've run into, but we can't possibly go through all these. We're already a 30-minute video. Outstanding known issues. Dynamic batching be enabled when using sprites. Yeah, that's normally built in by default. I'm pretty sure enabled by default for 2D projects. What if you start a 3D and then forget to turn that on? Where do you actually turn this on or off and make sure that it's working? If the option is unchecked, but where is that option? Is it part of the camera? I mean, I don't think so. Is it part of the render settings? What do you have, like quality or graphics? I don't know. I don't know where you would explicitly turn that on or off. Because sometimes what you do, like I said, sometimes you start a new project and ask you if it's a 2D or 3D project. And I've always said, if you accidentally go and hit 3D when you want a 2D project, I mean, it's fine. The only difference is that first, in a 2D project, your main camera will automatically set to orthographic. And will be set, I think, with a Y of 0. It'll be set like this, 0, 0, minus 10. There's that, and then the other thing you can do, when you start as a 2D project and you bring in images, it'll assume that it should be set as a sprite, whereas if it's a 3D project, it'll assume default, so just a texture. And so then you have to set it to sprite for each individual sprite, or you can go to Edit, Project Settings, and I think it's Editor. Yeah, Default Behavior Mode. So if you set it to 2D, then this will impact the default importing of various sprites and things like that. But what I don't know is the batching. How to force that on or off for 2D. No idea. I might have to look that up. Keep that in mind, though. Because that is turbo relevant. Turbo relevant. Because, yeah, the 2D stuff can really be tightly batched. The reason is that internally, unless you use a custom shader on a particular 2D object, internally, Unity will tend to take all your sprites and sort of automatically make an atlas. Like, take all these sprite graphics and put them in one giant image for different things. But, like, sprite atlas packing is sort of something built into Unity here. We'll make them into one giant image. So, in practice, all of your sprites that you use in here are all going to be using the same material, just with different UV coordinates on this master atlas over here. And it means things can be batched very, very, very aggressively. So yeah, knowing that would be quite good. I will have to investigate. But I think that's going to bring us to the end here, because again, we're not going to be able to go through all this stuff over here. So hope this was vaguely useful to you to explain a little bit in context what the deal is with 5.6. I am going to be upgrading to 5.6. I already have, and I don't see any reason to suspect that I would be downgrading back to 5.5 for any reason whatsoever. It just seems like an improvement. A lot of things are little bug fixes and stuff that I won't even notice, but turns out will make my life a little bit better. Having more performance everywhere is good, and some of these new features I will definitely be making use of at some point in the future. Thanks for watching. See you next time. Thank you, all our March Patreon supporters and these Mic Check supporters. We've got Yukofin, Snoopy TRB, Pavel Zdanov, Drazion, Gavin Power, Jan Torre Vel, Michael McClintock, Aaron Doibson, Craig Mortel, The Not So Evil Engineer, Julian Ogelafon, Maris Fieldvold, Speedy Savant, Steven Stager, Valiant, that's probably Stager, I don't know, Valiant Cake Fiend, Jason Yanity, Stephen Bonnerman, Kale the Quick, Neil Blakely, Milner, and everyone who has watched, shared, favorited, and subscribed. Thank you so, so much.